Recording started.
Good afternoon. Nice to see you all this afternoon. Welcome to this session. My name is Bob Campbell, and I represent the ACM Committee for Computing Education and Community Colleges. So I've got this little brochure. I'm not going to talk specifically today about the committee. I'm going to talk about the committee's work. But I invite you to go to the website, capspace.org. CAPS stands for Curriculum Assessment and Pedagogy. There's lots of resources there. And we're going to talk about those sorts of resources in the context of the information that I share today. My real job is Vice President of IT at the Graduate Center for City University of New York, right in Manhattan, New York City. And so my background currently is in a PhD granting institution. However, the first, 20, 25 years of my career was spent in the community college sector. So I have a great fondness of the community college environment, and a lot of time working there, both as a faculty member and administrator. And the committee that is highlighted in this brochure has existed for 20 years now. Is a subset of ACM. I don't know if you're familiar with ACM. Any of you familiar? Okay, familiar with the working great. It's really the premier professional society for computing practitioners and educators alike, and puts a lot of resources into the arena of education. So, by way of a little bit of background, the Junior College Committee has, over the last several years, developed curriculum guidelines in computer science and software engineering in different fields. The last time we produced guidelines for IT, the phrase IT didn't really exist. And those guidelines were called Guidelines for Programs in a Networked Environment. And they included desktop computing and web development, networking, as three sort of main prongs of that. That work hasn't been updated in some time. And so the question arose, well, is it appropriate for the ACM Ed Board to charge the Junior College Committee, the CCECC, with developing guidelines, updated guidelines, curriculum advice, in the area of IT? You know, should we fund that or not? Some of you may be familiar with SIG-IT, which is a special interest group for IT education, and SIG-IT produced 4-year curriculum baccalaureate guidelines in the area of IT that were adopted formally about a year ago, maybe a little over a year ago. And hand in hand with that, they produced some 2-year college guidance as well. And that's fine, sticks do that routinely, not a problem there. But that hasn't been endorsed by the ACM Ed Board. So the Ed Board said, what should we do in this arena? So that's the task that we, the committee, took up, was to investigate that. So let me tell you how that's gone. And I'll mention that the work that we've done at this point has been phase 1. Phase 1 is identifying should something be done. And if the answer is yes, then phase 2 will do the something that should be done. Okay, so it's kind of a two-phase approach here. So to start with, we assembled this group of individuals as a project team. And undoubtedly there's some names that you're familiar with. Certainly there are people on this list that are here at this conference and have been very active in this field. So we felt good about the collection of folks as representative not only of the 2-year college teaching environment, also the 4-year college environment, university setting, ACM, and of course business and industry. So these are the folks that have been debating this question with us. And the place we started was to say, if we're going to have a conversation about curricular guidance for IT programs, it would be helpful if we could identify an IT program when we see one. So that raises the question, well, what do you define as an IT program? So we put together this list and said to this group, which of these are IT programs in your own mind, based on just sort of your reaction to these? Now I'll tell you, each of these titles is a legitimate degree at a senior college someplace in America. These are not made-up titles. They're not certificate titles. Sometimes certificates tend to be, a little more specialized in language, depending on maybe the local industry. These are all degrees. In some cases they are AA, in some cases they are AF, and in some cases they are AAF. So we had fun with this activity, and I'm going to let you, now that you've had just sort of a moment to look at these, I'm just going to ask you the same question, and we'll do just a quick show of hands. And nobody's going to hold you this, so it's not so much about being, you know, highly deductive in thinking through your answer. It's just a reaction. So in your mind, computer drafting technology, would you say that's an IT degree? Anybody? Nobody suggests? Okay. Industrial mechanics technology? Any yeses? That's an IT degree? Nope. Okay. Instrumentation technology? No yeses on that one? Nobody thinks that's an IT degree? All right. Process operating technology? So we got an awful lot of degrees here with technology in the name, and none of those struck as IT degrees. That's fine. Industrial instrumentation technology. Maybe it's not instrumentation, maybe that's that bio stuff. Anybody see that as an IT degree? No? Are you traditionalist? Electronics technology. Yes. That you see as an IT degree. A couple people. All right. Bioinstrumentation. Okay, maybe. Okay. So that's kind of hard. Depends on where you're coming from. Biotech. Is that an IT degree? There are a lot of schools that have the heavy emphasis on IT. Okay, now we're getting into that. Offering the we're offering the biomedical and informatics which has a lot of IT. A lot of IT, especially often a lot of database data. Yeah. Diagnostic medical sonography. I have no idea what that is. Okay, so you're not thinking that it's an IT degree. All right. Electrical technology. Yes. Okay, so we have a couple of yeses on that. We got a little more liberal impression over here. Electronics technology. Is that an IT degree? It looks like maybe we got half the people here. Oh yeah, let's repeat it. So that's quality control to see if you gave the same answer. Engineering design graphics.
It could be graphics to anything though. It could be IT graphics or it could be graphics for packaging.
Okay, so the observation you're making is that we need more information, right? You can't necessarily draw quick conclusions from titles. But we're going to do it anyway, just because we're playing. Health information management. Oh, we got the most number of hits so far on that one. Okay. Maybe because it's got the word information in the title, it strikes us a little more IT-ish. Paralegal. No? You might even ask, well, why on earth is that even in the list? Well, lots of databases, lots of data mining. There's something now called computational journalism, which is different than regular journalism. It's all about data mining, looking through all those records of zoning board minutes and things, right? Video and film production. Portions. Portions are IT-ish. Okay?
And the underlying network and data communication. A lot of video editing that's done interactively offline.
Sure. If you're going to do this, you better be pretty darn good at Final Cut, right? Right. Visual communications.
And that's where on my campus we use the share.
Okay, that's a shared program?
Yeah, I'm in computer science. There's visual communication on share.
And so your point is well taken, which gets at the notion of interdisciplinarity, right? Avionics technology. Okay, not quite as compelling. All right, that's fine. Medical informatics. Yeah, you were mentioning bioinformatics. Okay. Oh, that got I think that was almost unanimous on that one. GIS. Okay, lots of people like that is an IT degree. Computational science. Do you believe there's actually an AA degree called computational science transfers to a local university? That just amazes me. Okay, so that's the question. Contacting, if you're going to create curricular guidelines in IT, you better be able to figure out what IT is. Well, in the same way that you all were sort of yes and no and maybe and it depends and we're not sure, the group that we assembled had exactly the same reaction. And the more they thought about it, the more they asked these kind of questions. Well, Bob, you put the wrong titles up. You're supposed to put up things like web development, computer security, forensics, game design, all those titles where we automatically, oh yeah, that's an IT degree. But what these do is make you stop and think, well, where are the boundaries? And of course, we know that really it's hard to put a boundary around the concept of IT because it infuses everything. I mean, I'm not telling you anything that you don't know. And so in some sense, teaching IT has become almost teaching a service component to multiple disciplines across the campus. Right? There's a lot of work going on now in the area of interdisciplinary computing. And the question is, what should NSF do to support interdisciplinary computing? Because it's seen as the great driver of innovation and development of a lot of disciplines. All right. So the challenge is pretty large. On the other hand, you can step back and you can say, well, what if instead of looking at the universe of all things that might be considered IT, what if we look at the intersection? So what if we say, of all those degrees that one imagines are IT degrees, or one imagines that have an IT component, as you were saying and others were saying, if we look at the intersection of those, clearly there are IT skill sets, IT concepts, IT ideas that are common to a lot of these disciplines. So the group went that route, and they said, yeah, there is a compelling need for curricular guidance, but the way that a lot of curricular reports at ACM are developed is you start by defining what's the body of knowledge. And within that, you go through this whole process. And if you look at any of the IT curricular reports, you'll see they're highly structured and there's a lot of value to that. But those disciplines are typically much better defined. It's not rigorously defined. At least most people feel like they know a software engineering degree when they come across one. Right? You typically feel like you know a computer engineering degree when you see it. But obviously, it's clear we're not as confident about defining an IT degree. And so what the group said was, let's not go that route. Knowledge units that are made up of topics, et cetera, all that sort of hierarchical structure. Let's take it a different approach. And so what would that approach look like? Well, IT-related degrees at the associate level are so varied. Let's look for that core. Let's try to find that core. And then once we can identify that core, let's look for a blended model of curricular guidance. Let's stay away from the knowledge units and all that. Let's do something very different because IT has become the sort of service element to so many different degree programs. And so how can we get our hands on that? Also, let's take note of the fact that IT changes so fast that whatever you do today is outdated very, very quickly. So how do you create some system of guidance that has staying power? How do you do that? Well, the idea is to build it around learning outcomes. So throw out the whole notion of let's start with topics, let's start with knowledge units, let's start with the knowledge areas. Forget all of that. Just throw that out and say, let's start with learning outcomes. What is it that you expect the student to be able to do with this core knowledge that then they take and they apply either within degree programs that still sound very much like IT programs, or in some other program. So if they're going to take this knowledge and they're going to put it in, they're going to apply it into a bioinformatics program, what are those skills? What are those learning outcomes that they will be able to take to that location, right?
But even learning outcomes is the dynamic process. It's not the same from one year to another. As you know, the criteria is changing based on our learning outcome. Every year they come up with a new criteria that the technology majors have to meet. So still you have to keep evolving the learning outcome to match the requirements for the IT.
Absolutely, your point's well taken. So it's hard. I mean, in a field this dynamic, it's hard. Yes.
Actually, to me, it poses the exact same problem when you call it a learning outcome or a knowledge area / topic area, etc. With a slight difference in the focus being what you teach versus what you learn. But ultimately, they have the same chronological problem that anything in IT has.
I think the sort of thrust of the group was that, let's take the notion of object-oriented programming concepts. If at the end of the day, the outcome that you want a student to achieve is that they can take some scenario and they can create from that an algorithmic-based approach to solving that might be implemented in any number of languages or scripting techniques or whatever it may be. This is development of an algorithmic process to achieve some outcome is the sort of core learning outcome that might have a bit more staying power than anything you could describe as sort of language du jour.
That is the mechanism to come up with the outcome of that would be a learning outcome. It's not a learning outcome that you're defining so that it will be the same. What I have tried to convince my department of medical university that perhaps similar to the English and math department that we require for every professional student to take, the basic knowledge of IT, no matter what field you are in, as you mentioned, it includes in all disciplines. That should be a basic requirement for every English student who's interested in studying, no matter what major they go in. Now, it has to be used in different courses to give that knowledge, or it has to be as a separate single course that every single student, a separate course, one credit course, have to take it in order to be able to continue their education. But it doesn't solve a lot of problems for them, because every student comes at a different level. Some come from a very solid background in computing and computers. Some come without any knowledge of it because they don't have the facility, they don't have any computer at home or whatever. So to bring them all at the same basic level, I think you need to introduce a single course to all the students at the first year of the college.
One of the related challenges is that to our colleagues in other disciplines, what they think of as IT skills will vary and will often be parochial to their own interests. Right? So the IT skills of somebody in bioinformatics are probably very strong database concepts. So the IT skills to somebody in a different field are going to be a different kind of skill. You're going to comment?
Yeah, if you present that to your curriculum committee, how well is that received?
Well, I've actually discussed the roles, and I'm a member of the curriculum committee of the college, and we're trying to make that happen. As you mentioned, it might be different applications in different areas, but that basic common element is the same. So it could be a one-credit course for everyone. So when they go to different departments, then the application in different areas is covered in their own courses. They have to maybe update their course outline to make the needed courses that include informatics, so that they learn that IT applies to their field. They have achieved the basic understanding of what IT is. Now they learn how they can apply to their own field.
And of course, a related issue is that it's not unusual for colleagues in other disciplines to expect that faculty teaching in the IT field are the ones who decide what those core skills should be. Right? I remember years and years ago, too many years ago, I would teach a mathematics course that was required for nursing students. and we met with the nursing faculty and said, what is it that you want your students to take away? We thought it would be ratios, stats where they could be converted to medical basing and things like that. And they said, just that math stuff. Which is math stuff in particular. And they said, we don't care. The reason that we require this course is because of the rigor that it introduces, and also it weeds out all the bad students for us. We said, okay, well, you're very welcome then. That doesn't get the conversation going very much further. IT, of course, is different than that. That's still true of mathematics. People just want that sort of rigor. But IT is different because IT often is built around a set of very discernible activities that students can do. Let me go to the next slide and see. I love your feedback because none of this is all draft, what I'm showing you. But, if you put that watermark on there, it just distracts. So, all right, this is a long bullet point, but it really captures a lot of what we're saying. There are, of course, these traditional titles, desktop support and networking and all those sorts of things. But then you've got computer forensics and game design and health information management. These kinds of titles that y'all were reacting to a little bit ago that you said struck you as more like IT. And so these learning outcomes should focus on some kind of core and should be built around some collection of competency domains. Some people use the word pillars. That shows up sometimes. The IT competency model is one that's available. There are different models that people put together. James sort of stumbled up against this idea this morning in some of the things he was talking about. The idea being that one way or another, at the end of the day, you can take a collection of core, we use that word in quotes, IT learning outcomes, and you can group them into different domains of competency. Right? Do you believe that? It's helpful if you believe it. Since it's already written, if you don't believe it, we have to change it, and I'd rather change it because you don't believe it than just accept it. So I know that's a lot of text right there on the screen, but does it strike you as reasonable? Okay.
I don't think you have a core of problem solving and procedural and ways of thinking skills. No matter what kind of language or what kind of technology you're using.
And then somehow that core shouldn't just appear as some conglomeration. There should be some kind of structure that one can discern among the collection of learning outcomes.
Moving from machine to machine, OS to OS, or fill in the blank, you should be able to approach it and figure it out.
Now, everyone in the room that's a faculty member, of course, what you think of when you see this is courses. Oh, we have a course in this, and we have a course in this, and we have a course in this. What we're specifically trying to get away from is the notion of the sort of one-to-one correspondence that you see so often when you look at a curriculum report between, oh, I know what that is. That's my database course. Oh, I know what that is. That's my data structures course. I get that. I get that. So we're trying to break that sort of mindset. You're the first group that's ever seen this information. You're very special.
Wow.
Yeah. I may have to question you all. So let's see what the next bullet says. Okay, they shouldn't be overly technology specific. Bit of a fine line there, right? Or prescriptive. They have to be crafted in a manner that ensures they have reasonable staying power. As we were saying earlier, these are pretty big challenges. They have to be adaptable. And then, of course, you get into this mission as a community college, right? This sort of traditional three-pronged mission. You've got students that are immediately entering the workplace. You've got students that are going on to baccalaureate programs. You've got students that are back for very targeted retraining, call it what you will, right? And so if you're going to say these are the learning outcomes that we should be able to find among your IT curricula, it's got to serve these different domains, different goals for different students. So that's a lot to take on, but of course that's what community colleges take on every day. Can you imagine that a learning outcome that you might sit and craft for an IT curriculum that's intended to serve a transfer student might be very different than one that's intended to serve the needs of a very localized industry. Is that reasonable to expect?
Well, here, if they're core, the answer is no.
No, if they're core, they have to be for all of that, including the person who comes back for specific needs. And everyone will need that core.
But the specific industry, they call it in the specific application. The code can only cover the basic fundamentals, but it cannot cover that field applied to so many hundreds of different fields. So it's very difficult to match the core with any specific field that student will be going to. The transferability of the curriculum, as you very well know, the CUNY has this general thing going on that makes it common for all the students to transfer from one CUNY campus to another. And if this IT, as I mentioned, is created as a course that we taught for all of the students as part of the general education, then the transferability is very easy. They can go from one part to the other because it's part of the general and the general is coming from all the campus.
In theory, right?
Yes.
Well, I was going to say that almost to put core and IT skill sets in the same sentence is almost in and of itself problematic.
Go ahead.
In that, because of the incredibly dynamic nature of IT, the processes, even the ones that most have longevity, like object-oriented processes, really don't have enough longevity to be what I would call a core skill, knowledge, effort for thinking, being able to think on multiple levels is really, in a sense, the core thing you need to develop. And that is, yeah, and I don't even like to use that because it really limits creativity from the process. But it's almost like you're trying to do two divergent things here at the same time that don't lend themselves to being in the same place. And I think defining core skill sets is critical, and I think that defining the more fluid moving targets that IT or IT serve are important, and that we simply need to make sure that what those are changing.
So I think the group that's been discussing this would suggest to you, not that they sort of crack that nut, right, but that emphasizing learning outcomes is an effort to mitigate that phenomenon, not to necessarily resolve it. And in some way you can say, well, Bob, all you did was take the big question of what's IT and reduce it to another question that maybe is just as equivalent, and that is, what's core IT? Right? So what is this core that we're talking about? But again, don't think about it as a collection of sort of knowledge components, but more about learning outcomes in an effort to circumvent what you're talking about.
It is how, well, see, I think in IT, it's almost better to just start with the assumption that every 2 to 3 years we have to rethink what we do and adjust accordingly. And I get concerned when I look at learning outcomes, or as we say, your student learning outcomes, that they are not fluid enough. And part of why they're not fluid enough is because in terms of defining our course outline records and the SLOs that we're going to assess for an accreditation review, on one hand we're told, limit the number, make it on a per course basis, only a few things And that's mostly for an administrative standpoint, that otherwise the record-keeping process and the reporting process becomes way too intensive and way too much burden. And whereas what we used to call course objectives, which often should 6 to 10 of those in a course outline of record, really told you more about what was happening in that course than a learning outcome really actually tells you.
And presumably a learning outcome is again, from the notion of a sort of core outcomes, it's not necessarily a one-to-one relationship between a learning outcome and courses. Right? So a given learning outcome may be achieved as an aggregate of a student's experience across more than one course.
I think, if I can just add one point, I think the learning outcome that perhaps is referred to is not the course learning outcome, rather it is the program learning outcome. So when the student finishes the whole program, they should have achieved these learning outcomes. Right? The thing that makes it difficult is because the learning outcomes are so dynamic and so changing. If you invest every single one of these learning outcomes in different courses, then in 2 or 3 years you have to monitor so many courses to come up with these new learning outcomes. Whereas if it was a single course, then it would be much easier to redefine and add new items to it. Whereas it is 10 different courses that each course contributes to one of these learning outcomes, then we have to change all these 10 courses.
One of the observations that this working group made was that they really wanted to capture the notion of emerging technology. And so how do you create a learning outcome beyond the sort of typical lifelong learning concept that a lot of us talk about? But how do you really craft a learning outcome that somehow engages students in the ability to be part of emerging technologies? These are not easy things. I went to the next slide so we can keep moving. Your comments are fantastic. I'm assuming all of you are going to volunteer to be part of this effort. So afterwards you can say, Bob, here's my card, put me down. So this slide talks about the great need for business and industry, government, standards bodies, certifying agencies, to be a prominent voice in crafting these learning outcomes that we're talking about. That for IT, perhaps unlike any other discipline, but certainly unlike a lot of disciplines, really this core set of skills needs to be reflective of the input of business and industry. And then, of course, a comment at the end here about emerging technologies and soft skills. Soft skills, professionalism, whatever your favorite phrase is for that. Yes, ma'am.
Well, I've got my computer science degree in 1967, so needless to say, I've seen a lot of changes. So I was thinking about what you're talking about and trying to think, well, what is it that carries me forward? One is you have to be curious about new things, you have to be a flexible thinker, you have to be a good problem solver, but those are almost personality traits.
The talk I was in just prior to this one, in the previous session, there was a woman speaking about integrating soft skills into courses, and she kept coming back to the word passionate.
Yeah, that's it.
You know, I don't think you can teach passion, right? People have passion or they don't. Sometimes they are passionately opposed to the course that they happen to be taking. But passion is, as you say, it's an innate human characteristic.
Curiosity.
Right? Okay. Well, let me go to the next slide. And some of these you're going to say, yeah, that's obvious, but things are always obvious once they're written down. IT, of course, spans time zones, it spans boundaries, it doesn't know the difference between, different economic systems. And in particular, this phenomena of IT as a driver of economic development is playing out the same in many, many countries with regard to education. Many countries are now saying we want our educational system to produce students that have these kinds of technology skills and can then grow our economic base. Okay? So from that perspective, the idea of some kind of IT core shouldn't reflect American education. It should be crafted in a way that is much more universal than that. And so again, you might say, well, of course. But if you look at a lot of the ACM curriculum guidelines that have been produced in the past and are still being produced, they're very U.S.-centric. You know, especially from the perspective of transfer between lower division and upper division community colleges to university systems. They're often very U.S.-centric in terms of how they think about courses and a lot of things that we take for granted, semester systems and all those kinds of things. In a lot of other places, those concepts may exist, but in a different way. It doesn't make these reports as suitable for adoption. So the idea is that an IT report should be really reflective of a much larger audience and should capture a core that is meaningful, again, not from the course and semester and we have so many hours and all that kind of stuff, but from the concept of learning outcomes. That's the idea here. Comments? Yes?
I don't know how much you're familiar with the United Nations Task Force for ICT that started in 1999. The program is matured by 2016. But in that ICT task force, which is under the supervision of the Secretary General Office, they focus, as you mentioned, internationally, what ICT, which ICT is part of it, is contributing to the economic development of all of the member countries. So they're looking at it with a wider perspective, and perhaps looking at those documents, but they have published books, volumes of books on these issues. It could help to come up with something which is more universal than it is only US-based.
That's an excellent point. You see similar efforts in Australia because they're closely related, of course, to the UK system. They've done a lot of work there with outcomes-based.
The United Nations, which in context is also.
Oh, okay. All right. No, I'm not familiar with that. That's good. Okay. Any other comments there? Let's look at the next slide. So it's all well and good to talk about having a collection of learning outcomes. The learning outcomes shouldn't stand and can't stand by themselves. You have to have assessment techniques. You have to have meaningful rubrics. You have to have evaluation measures that are legitimatized and vetted. And one of the things that this working group talked about was the fact that if we get a group of people to sit together and we say, okay, we're all bright, talented, experienced people, familiar with IT and education and the business needs, let's come up with what those core learning outcomes should be. And suppose that we constituted such a group and we did an outstanding job. That's not to say that the same set of folks would have any ability at all to craft associated assessment rubrics. So people that are really talented and knowledgeable at creating the appropriate learning outcomes might be a different collection of people than those that are talented and knowledgeable about crafting assessment rubrics. You might actually be looking at people with sort of two different groups, as it were. What's your reaction? That's one group's opinion. What's your opinion?
As teachers, they expect us to do all of that and more.
Well, sure. That's why you get paid what you get paid. Come on.
Right. So they expect us to be good to really whatever else they really need with all of us.
What's your own expectation of yourself in that regard? Do you expect yourself to be as talented at creating curriculum as you are at creating assessment techniques?
When I first started back in the community college after implemented in industry, I thought that was a joke, and that I shouldn't expect that of myself or anyone else. And through the years, I think I've changed a lot in how I think about it. That my opinion has changed.
Mm-hmm.
And that I see that there's certainly a little bit in. And I expect to share those with others who have other areas that they're really good in.
Interesting. Yes?
Yeah, I tend to agree with that because your experience in one area almost necessitates growth in the other. My one concern here is I see a program in the development called No Feet Left Behind.
No, that's not. Is that trademark? Is that copyrighted? Can we just take that?
Yeah. And I have definite concerns because where this looks like it's going is creating a standard set of assessment rubrics across a wide geographic extent of the world, based on the previous slide.
Yeah. But just this planet.
Okay.
They're on their own.
And on multiple levels, I have a problem with that. One being, again, the fluid nature of ICT, being that the amount of time that it would take to develop an agreed-upon set of standards has the same problem as a typical computer. And I always joke with this with my friends that, they'd ask me, well, should I buy a computer now? They're coming out with a better one in 6 months. Mm-hmm. My joke is, if you own it and it works, it's obsolete. But the other joke is that if you own it and it does everything you want it to do, it's never obsolete. And my concern here is that this process of trying to have a cookie-cutter, standardized approach of this size and magnitude takes away any ability to be fluid dynamic in this industry. And it also takes away an even bigger area that I'm kind of morally opposed to, is I tend to prefer a constructivist approach to learning rather than an objectivist approach to learning. And this is one of the differentiation between them. Okay. In objectivists, we do this. We define objectives. We try and get people to them. And it's traditionally what we've always done in education. In a constructivist environment, we look more at the student as an individual, not only as where they're at right now, but where it is they want to go, and try to give them pathways to get to their objectives, not the ones that we define. Now, in reality, the student is always trying to find something that's close to what they want, and they'll live with an objectivist approach because that's how they're offering. But I think we ought to offer more and be more fluid dynamic.
I'm keeping an eye on the clock, so I jumped ahead to the last slide, which is simply to capture all the previous bullet points that we've been talking about. So this is not new content, it reiterates, so we can continue the conversation. Did I see another hand? Yes?
Well, just make a comment on the larger slide that to meet the requirement of the colleges and industry. At the same time, there's approach to listen to the advisory commission that all the departments around the country have, and they meet regularly every semester, at least in one of themselves. And they operate the department of what is out there in the industry and what you need to change in your curriculum to meet the needs of the industry. So if you have people from the industry that are experts from IT industries and they can update you, so you keep that update always in such a way that it meets the college's requirement and also where the students graduate in the industry.
Absolutely, and I'm sure every school represented here uses advisory committees with varying capacities, perhaps for different degree programs and different purposes, right? Those are very, very valuable, and that guidance can not only influence curriculum, but can influence administrative decisions about resource allocations and things of that nature. So those groups are critical, and in no way would we want to detract from that role or that importance. But the concept is to see that ACM as a professional society sort of puts its stake in the ground and says this is what we consider to be IT core learning outcomes. Okay, that's the concept. Again, you can accept it, you can reject it, and your opinions are very valuable in helping us shape that notion. Yeah.
I just think it's fabulous that ACM is tackling this. It's really, really hard to do.
Yeah, we covered that in the first slide.
If we don't have technical standards, technology doesn't work. And yet we use standards in the academic environment, and all of a sudden everybody gets left. We do need advisory groups, but we have them, and they produce fundamentally different results in different schools. So that our credentials are so diverse, they almost lose all value. I think the challenge is coming up with standards that are not content-based. As education, we tend to think that what we're trying to do is help people be able to regurgitate this set of facts or this set of rules or something like that. And that's not what it's about in this world at all, because that stuff's going to change constantly.
Right.
It's more about, can you do this thing? Can you solve a problem? Can you investigate your technical options, figure out some solution, apply it, and make it work? And so being able to state outcomes in those sort of ways allows flexibility for change technology. And those are the outcomes that you're looking for in your workplace. Nobody cares if you can pass a multiple choice test in your workplace. Can you add value to our enterprise by solving problems and building something that meets the infrastructure needs of our program? It's a hard, knotty problem, but we need it. And thank you, ACM, for attacking the problem.
So where we stand today is that I've shared with you the preliminary conclusions, recommendations of the working group. These will go through a refinement process. Then the ACM Committee will formulate a formal recommendation to the Ed Board, and then we'll see what they do with it. They may decide to fund it. They may ask us to rethink some things. They may just say no altogether. We don't know. But of course, one can't imagine that the questions put on the table without some expectation of action going forward. And to that end, here's my email address. I want to hear from all of you. You can send me a note and say, Bob, that was fantastic, and I want to be a part of it. Or you can say, Bob, that was a bunch of hooey, or balderdash, or whatever language you want to use. But let me hear from you. So my name is Bob Campbell, so it's R for Robert, Campbell like Campbell Soup. And then it's gc.cuny.edu, right? This is our website. I'm going to pass out a couple more brochures if you didn't get a chance to get one. And let me put a business card in your hand if you're interested. And I think our time has expired.
Our time is up.
Thank you very much. Your comments are very helpful.